Today we're looking at adaptation and how different species are adapted in different ways to survive in their particular environment. There are questions, and when you get to those you need to pause the film, have a think about them, see if you can answer them, then you can restart and continue. When you get to the end, there is a glossary of key words, and it's probably a good idea to learn those before you go on and answer the quiz. Okay, what is adaptation? Questions. What are trophic levels? Number 2, what are scavengers? Number 3, what is biomass? 4, what are decomposers? Okay, pause the film. See if you can answer those ones. Think back to last lesson. Any of it seem familiar? Feeding relationships are shown in food chains. Each stage is a trophic level. 2. Scavengers are meat eaters, but rather than catch prey, they prefer to feed on animal remains left behind by predators. The most common scavenger that we're probably familiar with is the vulture. Biomass is a measure of the total mass of living material in each trophic level. A decomposer is an organism that decomposes or breaks down organic material such as the remains of dead organisms. Decomposers include bacteria and fungi. They also include scavengers, and when I think about the woods, I think of wood ants. What is adaptation? Well, let's start off. There are 3 major types of environment. They are land, fresh water, and the marine. Well, I say there are 3 environments, but it kind of depends on who you ask. Some people say that there are only 2 types of environment. There is the natural environment and the man-made environment. Other people suggest that there are more than 3. There's the desert environment, there's the polar environments, but let's just stick with our 3. So land, fresh water, and the marine. How do organisms survive in each of these different environments? Well, they survive by adapting to them. All organisms are adapted to life in general, such as having legs for walking, wings for flying, or leaves for photosynthesizing. These are general adaptations. Organisms also have specific adaptations. These are special features or behaviors that have evolved to make an organism particularly suited to its environmental niche. Let's have a look at the shark. Now the shark has got a streamlined shape to reduce friction when moving through the water. Its gills have a large surface area so that oxygen can be extracted from the surrounding water. And it's got fins that provide stability, power and control. So those are its general adaptations. Its specific adaptations: it has specialized sense organs that can detect the sound, movement and electrical fields of other organisms, which is pretty impressive. It has a highly sensitive sense of smell that can detect drops of blood from miles away. And lots of very sharp teeth that are constantly replaced, and silver colouring underneath acts as a camouflage. So the shark has got general adaptations and it's got specific adaptations. And for a shark, they are really successful. The earliest fossil evidence for sharks or their ancestors are a few scales dating back to 450 million years ago during the late Ordovician period. So sharks have been around for a very long time. Shark's teeth are not fixed to its jaw but embedded directly into the flesh. Its teeth are very sharp but are constantly replaced as they fall out or are broken, so that a shark may get through thousands of teeth during its lifetime. The lower teeth are mainly used for holding prey, while the upper teeth are used for cutting. The shark's specialised sense organs include lateral lines, which are a row of fluid-filled sensory canals along each side of the shark. These can detect movement and changes in pressure from about 100 metres away. And small pits in the shark's snout that detect tiny electrical fields, such as those associated with muscle contractions of prey. In an auditory system, they can detect the sound created by an injured prey from over a mile away. So the shark has got lots of adaptations that help it survive, and it has survived for a very long time. In comparison to the shark, I suppose, human beings are newcomers. Why is it important that organisms are adapted to their environment? The better adapted an organism is to its habitat, the more successful it will be when competing for resources such as food and mates. This increases the organism's chance of survival, and so increases its chance of reproducing and passing on its genes. A predator is an animal that hunts and kills other animals for food. There's a nice picture of a predator there, and you can see what its prey. Well, if you look carefully at that picture, predators can be either carnivorous, that means they eat meat only, for example wolves, or omnivorous, they eat meat and vegetation, for example humans. A prey animal is one that is attacked and eaten by a predator, in that case the mouse. Predators are adapted to hunt, catch and eat prey, and the prey are adapted to avoid capture from the predators, and both of them have adaptations to help them to do this. The predator may have excellent vision for spotting prey from far away. Many predators have binocular vision to accurately judge the distance of their prey. Binocular vision means that their eyes are close together at the front of their head looking forward. High speed for chasing after prey. Predators often stalk their prey using stealth and sometimes camouflage to get as close as possible without being detected. Weapons for killing prey. They are predominantly sharp teeth, claws and beaks, which enable the predator to hold their prey and tear their flesh. Adaptations of prey. They have excellent vision for spotting predators from far away. Many prey have a wide field of view to see predators approaching from all different directions. So their eyes are set further back in their head so that they can see to the sides of them and behind them. High speed for escaping from predators. Prey animals such as deer and antelopes often have a high stamina to keep running for longer than their predators. So if you watch these natural history documentaries, you have the predator which chases after their prey, and if they manage to escape, then they can eventually outrun it because the predator does not have the same levels of stamina. Camouflage for hiding from predators. For example, the stripes on a zebra break up their outline. Stick insects look like twigs, some insects look like leaves. Now the zebra, we might not think it's a very good camouflage, but cats can only see in black and white, so they don't have colour vision. So for the zebra, its black and white stripes are good camouflage. Defense for protection against attack. Examples include armor plating, horns and tusks. The adaptations of the snowshoe hare. It's got greyish brown fur which turns white in winter for camouflage. It has large ears that help detecting in predators. Monocular vision with wide field of view to see the predators approaching. You can see that their eyes are further back on their head. Large furry feet act as snowshoes and protect the soles from the cold. So there we have the snowshoe hare, and this is the thing that hunts it. This is the lynx. This is the Canadian lynx. So it's got excellent binocular vision for judging distances. See its eyes at the front, close together. A warm, thick, furry coat protects it from the cold. Very strong hind leg muscles capable of pouncing 6.5 meters. And it's got extra large paws which act as snowshoes. Sharp teeth and claws for puncturing flesh. So that's the adaptation of the lynx. Now, some animals use poison. Poison has evolved as an adaptation of predators and prey. Organisms such as snakes, spiders and insects use poison to paralyze or kill prey. Other organisms use poison as a defense. Certain tropical frogs have poisonous skin that can make predators very ill or even die. They are often brightly coloured to deter predators from even trying to attack them. So there are certain tribes in the Amazon who will use poison arrows, and the poison that they use on their arrows come from the skins of these poisonous frogs, which are quite deadly. Mimicry. Some harmless organisms have become adapted to look like dangerous species. This is called mimicry. We've got a hoverfly that looks suspiciously like a wasp or a bee. This warns predators to stay away, even though the hoverfly is incapable of stinging. I haven't got a picture of it here, but I have seen pictures of moths and butterflies which appear to have eyes on their wings, and that's mimicry. So let's have a few questions, see if you can remember anything. So, name 3 major types of environment. What is the difference between general and specific adaptation? What is mimicry? We've just had that one. Name 3 general adaptations of predators. Name 3 general adaptations of prey. Okay, think about that for a moment. Pause the film and come back to it. Okay, answers. 3 major types of environment are land, freshwater and the marine. As I said before though, it depends who you ask. General adaptation is a type of adaptation that makes an organism suited to life overall. Specific adaptation is a type of adaptation that makes an organism particularly suited to its environmental niche. Mimicry is the resemblance of one species to a more dangerous species for protection against predation. 3 general adaptations of predators are excellent vision, high speed and weapons. 3 general adaptations of prey are excellent vision, high speed, camouflage and defences. Though of course there are 4 of them there. Let's have a look at a polar bear. So a polar bear is the biggest type of bear, I believe. And there's an example there, looking very cute. There's white greasy fur that repels water and acts as camouflage. Thick fur and body fat insulated from the cold. Large wide feet spread the body's weight and act as good paddles and snowshoes, so it doesn't fall through the ice. Other adaptations that the polar bears have. Small ears and small body surface area to volume ratio reduces heat loss. Right, so it's got a small surface area in comparison to its volume, so its heat loss is small. Eyes have brown irises to reduce the glare from the sun's reflection. I didn't know that one. Black skin is a good absorber of heat. You have to look at the picture to see what it means by that one. The black skin seems to be on its paws underneath. I've also read that polar bears can see in ultraviolet. What this means is if you've got this polar bear which is out on the ice, and there's a cute little seal pup which is completely hidden because it's camouflaged white against the ice, the polar bear will be able to see it because of its range of vision. Camels, another interesting animal. Camel facts. Camels have 3 stomachs. Some camels live to over 40 years old. Some Bactrian camels can transport 450 kilograms. That's a Bactrian camel there, it's got 2 humps. Archaeological finds show that camels originated in North America and that Somalia is home to over 6 million camels. Well, there you go. Did you know any of those? How is a camel adapted? First of all, the fat is stored in the hump to reduce overheating. Little water is lost through sweating or urination. Long, thin legs help to increase body surface area and increase heat loss. Wide feet spread out body weight on shifting sand. It's got more adaptations, so these are specific adaptations if you like. Long eyelashes and furry ears prevent sand and dust from getting in. Nostrils that can close for protection during sandstorms. A very varied diet ranging from grass and bark to thorns and bones. How is a cactus adapted? Well, it has water stored in fleshy stems and a thick waxy surface to help reduce water loss. Leaves and narrow spines to reduce water loss and protect from predators. And roots are either very deep or shallow and widespread to catch surface water. Now that's a flower off a cactus. You can just see the cactus in the back there. Flowers enable plants to reproduce sexually. For this to happen, pollen from one flower must be carried to another flower, either on the same plant or on a different plant. This is called pollination. Pollination can take place in different ways. Pollen is carried by insects from one flower to another, or pollen is blown by wind from one flower to another. And there we can see a flower and how it's adapted for insect pollination. So it's got nectar. A source of food for insects is deep within the flower, so the insect goes deep within the flower to go and get the nectar. It's attracted to it because it's got colourful scented petals. It's got large sticky pollen grains. On that diagram or that picture you can see those large orange things in the iris. Those are pollen grains. Become stuck to the insect's body. Right, and they've got stiff anthers and stigmas are positioned where insects must brush past them. So they brush past those to get to the nectar. And then if you took a look at a flower which is adapted for wind pollination, you can see it's quite different. It's got no need to have bright coloured petals to attract insects. So it's small, dull-coloured petals. You can barely see them. Huge number of light, tiny pollen grains. Long, feathery stigma hanging outside flower so pollen can be trapped. Anthers hang loosely outside flower so wind can blow pollen. But you can see looking at that flower, it's completely different, and that's because pollination occurs in a different way. So it has a different adaptation. I love this one, unusual plant adaptations. This is a pitcher plant. So some plants can live in acid or waterlogged soils where there is little nitrate. Some plants have evolved a rather cunning adaptation to obtain the nutrients they need. Pitcher plants have a large hollow filled with fluid that traps insects or other small organisms that may fall in. Hairs on the slippery inside of the plant are angled down to ensure that the victim cannot escape. The plant digests its victim to absorb the nitrates it needs. So peach plant. It's quite an attractive plant. You may have seen the Venus flytrap as well. So that will digest flies. And it's amazing, really, isn't it, when to think about it. A plant has evolved which can trap insects. And at the end, we've got a list of keywords that we've used in the glossary. So camouflage, adaptation, mimicry, pollination, predator and prey. Okay, thank you for listening.